Today we are going to learn all about different types of chemical reactions. Why are we learning about chemical reactions? Because you take any chemical reaction in the world, it can be classified into these 5 types which are displayed on your screen right now. The different types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction reaction. Now we are going to learn about all the 5 types of reactions in detail. So let's discuss about combination reaction. So in discussion, let's say an element A is there which is reacting with B. The product formed is AB. Here I can say that A is combining with B to form AB. Such kind of reactions where the reactants are 2 in number, 2 or more in number, and the products are only 1, such reactions are called as combination reactions. Such reactions are called as combination reactions. So let's take an example. The best example is calcium oxide. Calcium oxide which is solid, will react with water, that is H2O, which is liquid. Now what will happen? They both react to form calcium hydroxide, CaOH taken twice, and along with it the heat is liberated. Most of the combination reactions are exothermic. Exo means out and thermic means heat. So when heat is liberated out, we call them exothermic reaction. We call them as exothermic reaction. So let's learn about the next type of reaction, that is decomposition reaction. In this decomposition reaction, it is divided into 3 types. Number 1, thermal decomposition. Number 2, electrolytic decomposition. Number 3, photolytic or photodecomposition reaction. Photolysis or photodecomposition reaction. If it mentions saying that thermal decomposition, therm means heat. So decomposition occurring in the presence of heat is called as thermal decomposition. So decomposition in the presence of electricity, we call it as electrolytic decomposition. Decomposition in the presence of sunlight, we call it as photolytic decomposition. So the decomposition reaction is again divided into thermal decomposition reaction, electrolytic decomposition reaction, and electrolysis or photodecomposition reaction. Decomposition reaction. Say if there is a reactant A, B. On further reaction, say on heating, if it splits into A plus B, we call such kind of reactions as decomposition reaction. We call such type of reactions as decomposition reaction. The best example we can give right is basically taken twice, and it's a solid in nature. If we heat it, it forms lead oxide, that is PbO, lead oxide plus NO2, nitrogen dioxide, which is a gas, plus oxygen. This is a solid. Oxygen is a gas. Now, the presence of oxygen can be tested by introducing an incense stick. So, let's look at a video and understand how the decomposition of lead nitrate is occurring.
As you can see, the decrypitation is taking place. As you can hear the sound, crackling sound. As you can see, the reddish brown fumes have started to come out. And now let me put the burning instance 6 inside. As you can see that the oxygen gas is making the flame more brighter. Oh, done, superb. So as you can check the presence of oxygen gas with the help of burning splinter. The oxygen gas burns the splinter, and here we have the NO2 gas as well.
If the decomposition occurs in the presence of electricity, we call it as electrolytic decomposition. Okay. Now when you talk about electrolytic decomposition, then what is the process of electrolytic decomposition? Basically, it is completely electrolysis process. Where anode and cathode are used. Where anode and cathode are used. Anode is a positive charge, positive charge electrode and cathode is a negative charge electrode. Negative charge electrode. If electricity is passed through cathode and anode, then the decomposition occurs. Okay. Suppose, let's take an example. Decomposition of water. Decomposition of water. Decomposition of water. In this decomposition of water, water splits into 2H2, hydrogen plus O2. This is also gas and this is also gas, and this is liquid state. There is a small video for you all and I want you to watch it carefully.
I'm going to show you an electrolysis of water setup. So we have a mini Hoffman apparatus, and I'm going to take this little test tube here and I'm going to dip it under and fill it completely with a 3 molar sodium hydroxide solution. I'm going to do the same with this one. So since we're starting with that completely filled up with solution all the way to the top here, it's going to allow us to collect gases in each of those. So we're going to run a red lead to the negative terminal of the battery, a black lead to the positive terminal. And when we do that, you can see bubbles starting to originate in there. I'm going to zoom in so we can see that up close. And that gas is collecting on the left and on the right. Over there. So we're going to let that run until we've collected enough to make a measurement. So let's go ahead and make a measurement here. So we're going to start by unclipping this. That way our reaction will slow down and stop.
Now there's a simple thing which is being on the screen right now. This you're observing, right? This is hydrogen. And this one is oxygen. Hydrogen is always double. Hydrogen is always double in concentration than oxygen. So without knowing what is cathode and what is anode, you can directly tell which is hydrogen and oxygen by the looking at the quantity which is being produced. So this is oxygen and this is hydrogen.